So recall, we said that absolute value functions contain an absolute value function, but are otherwise linear. When we want to graph such a function, we know that the graph is a V-shape. We just need to know where it is and how wide or narrow. In order to pinpoint that, we're going to do two things. We're going to find where the point of the V-shape is, and then we're going to find a point on either side to show us what the slopes of the sides ought to be. So here's how that's going to work. Suppose we want to graph the function f of x equals 2/3 times the absolute value of 2x minus 4, all minus 2. Our first step is to find out where the point of the V is. Well, remember from our original exploration of the graph of the absolute value that that point happens where the number inside the absolute value goes from being positive, so the absolute value leaves it alone, to being negative, so the absolute value takes its opposite. Here we want to know where 2x minus 4 goes from positive to negative. 2x minus 4, because that's what's inside the absolute value. Well, in order to go from positive to negative, a number has to pass through 0. The point of our V is going to be where 2x minus 4 equals 0. Solving that equation, we get that that occurs when x is 2, right? 2 times 2 minus 4 gives me 0. To find the y-coordinate, we'll just plug into our function. F of 2 equals 2/3 absolute value 2 times 2 minus 4 minus 2. And of course we chose that number 2 in order to make this part 0. 2/3 times 0, that's just 0. So we just get this negative 2. In this example, the point of our V is at the point 2 comma negative 2. Getting a point on either side is actually even easier. To get a point on either side, we want to just plug in one number greater than 2 and one number less than 2. We could pick any values of x that we like, but take a look at this fraction for a moment. We have a fraction with denominator 3, which means that we want to make sure that whatever we're multiplying this by is a multiple of 3. So for that reason, instead of just picking, say, 1 and 3, I'm going to pick numbers that are 3 away from 2. So being 3 away, that's going to be 2 plus 3 or 2 minus 3. So my first point, I'm going to take x is 2 plus 3 is 5. So then f of 5 is 2/3 times the absolute value of 2 times 5 minus 4. That'll be 2/3 times the absolute value. 10 minus 4 is 6, minus 2. Absolute value of 6 is 6. Multiplying that by 2/3 gives me 4. So I'll have 4 minus 2 is 2. My first point is x is 5, y is 2. For my second point, I'll use x is 2 minus 3 is negative 1. So f of negative 1, that's 2/3 times 2 times negative 1 minus 4, minus 2. So that'll be 2/3 times the absolute value of, that works out to negative 6, minus 2. absolute value of -6 is +6. 2/3 times 6, that's 4 again. So our second point is going to be -1, 2. So our points are going to be 2, -2 as the point of the V, and 5, 2, and -1, 2 as points on either side. So our axes might look something like this. And then our points are, the point of the V is at 2, -2. And then we'll have a point at 5, 2, and a point at -1, 2. Then to fill in our graph, we'll just draw the rays starting at the point of our V, coming up through this point, and starting from the point of our V and coming up through the other point as well. Notice when you draw this, you'll want to make sure that it looks like these are at least intended to be straight lines. We can check on a graphing calculator that our graph looks right. We'll just enter our original function was 2/3 times the absolute value of 2x minus 4 minus 2. These axes are a little bit longer than mine were, but we can see that that looks about right. I'm going to have you try one of these. Graph the function f of x equals 1/2 times the absolute value x minus 3 plus 1. Pause the video and try this now. Okay, so our first step is to find the point of the V. That happens where x minus 3 is 0, so where x is 3. Plugging in, we get f of 3 is 1/2 times the absolute value 3 minus 3 plus 1. So that's 1/2 times 0 plus 1, so just 1. The point of our V is going to be at 3, 1. We want to get a point on either side, and we want to make sure that when we multiply by 1/2, we get a whole number. So we're going to want to pick values that are 2 away from 3. So our first point is going to be where x is 3 plus 2 is 5. And then f of 5 is 1/2 times absolute value 5 minus 3 plus 1. That's 1/2 times absolute value 2 plus 1. Absolute value of 2 is just 2. 1/2 times 2 is 1, so this is just 1 plus 1 is 2. Our second point is going to be at 5, 2. And then our third point, we're going to take x is 3 minus 2 is 1. And f of 1 is 1/2 times absolute value 1 minus 3 plus 1. So that'll be 1/2 times absolute value -2 plus 1. Absolute value -2, that's just 2. So 1/2 times 2 is 1, plus 1 is 2. So our second point is going to be 1, 2. All right, so our axes just need to go out to 5. This point's at the bottom, right, so we're not going to be interested in any y values less than 1. Looks like we're not going to really be interested in any particularly negative x values either. So we might draw axes that look something like this. And then our points. The point of our v is at 3, 1. Our other points are at 5, 2, and at 1, 2. And then we'll just go ahead and draw the rays through those points. And there we go. There's our graph of y equals f of x.